Now let us learn something about the sieve of Eratosthenes. This is a particular method which is used to find the prime numbers. And in this particular lecture, we are going to find all the prime numbers from 1 to 102. So first of all, we are going to arrange the numbers in group of 6. So 1 to 6 in the first row, then 7 to 12 in the second row, and so on till 102 because we need to find only till 102. So first of all, we are going to highlight 1 means the very first number 1 in red because that is a special number, that is a unique number. It is neither prime nor composite. And then we are going to highlight all the prime numbers in green and all the composite numbers in blue. So first of all, let's start with the smallest prime number, which is the only even prime number, and let us highlight it in green. So 2 is a prime number, but all the multiples of 2, for instance 4, 6, 8, 10, 12, all the even numbers, but not 2, are composite numbers. So let us highlight all the even numbers from 8 till 98, and then 4 to 100 and 6 to 102 in blue because they all come in the table of 2. So they are all highlighted in blue. They are all composite numbers. Then we'll go to 3. 3 is a prime number because it only goes in the table of 1 and itself. So we're going to highlight 3 again in green. But all the multiples of 3, for instance 6, then 9, then 12, then 15, then 18 are all composite numbers. But as you can see, all these numbers are already marked as composite. So we're going to mark all the numbers from 9 till 99 as composite numbers because all these numbers are divisible by 3. So again, we are going to mark it in blue. Then we go to the next prime number. No need to consider 4. We shall directly consider 5. So 5 is a prime number. And we are going to mark it in green. And then we are going to mark all the numbers that come in the table of 5. For instance, 10, then 15, then 20, then 25, then 30, 35, 40. We are going to mark them in blue because they're composite numbers. So we are not going to mark the first number 5, that's prime. But then we are going to mark 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. You can see it forms a diagonal sort of thing. And then 60, 65, 70, 75, 80, 85, 90, 95, 100, 105 is outside this list. We're going to mark them in blue. So all these numbers which you can see in blue right now are composite numbers. Then we are going to go to the next prime number, which is 7. And we are going to mark 7 in green. And then we are going to mark all the multiples of 7 in blue. So 7 is marked as a prime number, but 14, 21, 28, 35, you can again see there is a diagonal in this direction this time. 42, then 49, yeah, this is still not marked. Then 56, 63, 70, 77, 84, then we have 91, 98, and all these numbers are multiple of 7. So they are going to be marked in blue. So all these numbers are composite numbers. Then we go to the next prime number, which is 11. And we know the table of 11 is very simple. 11 ones are 11, 11 twos are 22. But 22 is already marked. Then 33 is already marked. And then 44 is marked and 55 is marked. So from 11 onwards, 11, 13, 17, we need not take their tables because 11 itself is a prime number, but then 11 twos are 22, so we have marked the table of 2 already. Then 11 threes is 33, but we have marked the table of 3 already. We have marked the table of 4 already. We have marked the table of 5 already. And 11 sevens are 77, we have marked 77 because that comes in the table of 7. But then we have 11, 11s are 121. But 121 is outside this list. So from here, we can mark all the remaining numbers in green. because they are the remaining prime numbers. So all these numbers which are yet to be marked are prime numbers. So this is a very simple method in order to find out which of the numbers are prime and which of the numbers are composite. I hope you understood this. Thank you for watching.